This meeting is being recorded.
Okay, great. And I was saying thank you, Nishreen, for the introduction. And thank you, everyone. It's an honor to be here and share my learnings. Nishreen, can I start sharing my screen?
Yes, please do. I think you can.
Okay. Awesome. Can you all see my screen?
Yes.
Okay, great. What I would like to, in this 1 hour, I wanted to talk about what are some challenges and best practices when it comes to applied AI, or the production ML that enterprises need to put in production and reap its benefits. So my name is Benazir Fateh. Sorry, my voice is not. Give me 1 second. Okay, great. Sorry for the interruption. And my voice is, I'm not doing very well with my voice today. If I'm not clear, please let me know. So I'm an ML specialist at Google Cloud. And in this capacity, as Nishreen already mentioned, I work with Google Cloud's top accounts, helping them adopt ML and create scalable ML systems. So the topic for today's talk, first of all, a disclaimer. All the views that I present today are my own, and I do not represent Google in any capacity today. The agenda for today's talk is, first, I would like to start off with a little bit on the state of AI adoption in the industry as I'm seeing. What are the challenges that I see with companies who want to adopt AI? Third, I would like to talk about what are some best practices in making large-scale ML systems and putting them into production. And fourth, I wanted to quickly touch on, we mostly see the roles in AI organizations are data analyst, data scientist, and ML engineer. But if you have domain knowledge in an industry, and if you have learned ML, how can you apply that in other roles? So I wanted to touch on the other roles in an AI-enabled organization. Okay, great. State of AI adoption. So I'll start with that. So first is, what we are seeing is that currently, like worldwide, enterprises are spending a lot on AI in the last maybe 10-ish years. The business spending on AI is expected to hit $50 billion this year. And it's forecasted to double to 110 billion annually by 2024. And previously, like till a few years back, we used to see industries such as the digital natives and retail, those industries picking up AI a lot. But now even the other industries, the industries which weren't very AI savvy, like for example manufacturing or public sector, education, even those industries are now, they're wanting to adopt AI. But the sad reality of our industry is that, by industry, we are in the industry of providing AI or creating AI services for enterprises. So what we very normally hear, and these are here, I'm quoting some results of 2 surveys that were done. One of the surveys that was done by Algorithmia, and this was around in 2020. They found that the companies that they have surveyed, only 55% of those companies, only 55% were not being able to deploy a model, And it's all too common. We see that as a data scientist or data analyst, you create a model. I mean, you spend a lot of time creating that model, but then it takes a lot more time and many like processes and many hoops to jump before that model can see the light of the day, which is that it's actually deployed in production and it is used. It's deployed and your end customers can reap the benefits of that AI model. And why is that? There is a lot like of course our industry, there is a lot of growth in this last few years. There are new tools, new algorithms, new processes, and also there is a lot of hype. So when anybody who starts to learn about ML and data science, we start off with creating models. But there is a lot more that goes around it. Like once you have created a model, there are a lot of other things that need to happen before that model can be put into production. And what we see, like there is, before an enterprise can adopt AI, it depends on that enterprise's business practices, which decides how ready are they to adopt AI. So like mostly it can be divided into three buckets. So first is like tactical. So, these are industries which weren't thinking of AI. And, now that they may or may not have been collecting data, the data may or may not have been in a good, form. So these industries have started saying, okay, I understand the value of AI. I want to adopt. How can I focus on some quick wins and get started? By the way, one more thing I forgot to mention between my voice issues is I would love to keep this session interactive. Please stop me at any time if you have any questions. I'll aim to finish by in around 40 to 45 minutes. But I would love it if you have any questions. Please stop me and ask your questions. The second bucket is strategic. These are industries that already have some or maybe a lot of ML models that are currently deployed in production. These companies they have processes in place so that models are like, experimentation is encouraged, models are built, and there are set processes to put those models into production. So that, the pipeline there is a set pipeline. Whereas in tactical use cases, there might not be any pipeline. So, this example that I gave where like this was a famous tweet, it's been a few years that it was posted, that the model was developed in 3 weeks, but it's been greater than 11 months and it's still not deployed. It's because there was no process in place in that company to deploy that model. And the third bucket is industries that are transformational. And here I mean transformational in terms of their AI practices. So mostly, these are the digital natives of our world. Things like, think of Twitter or Uber. These companies are built, like when they started, they adopted AI practices right from the beginning. So here, data science and ML is part of their fabric. It's in their blood. It's how they think. And, more often than not, these are the companies which already have a platform. Because, it's only in the last few years that the major, like either the major cloud providers or other vendors have started providing customers with a platform, like an end-to-end platform. But before that, when there was no platform, these companies, so let's say Uber or Twitter, they had to create their own ML platform to democratize ML development and deployment. Now, I talked about, again, those three buckets that I talked in the last slide. They could also be like the entire enterprise. They could be teams in an enterprise, also possible. So I have seen that, when a particular organization or, a particular team says, this is my business problem and I want to create an ML model for it. people go, it depends on what is the expertise is there in the team and what are the tools they have. It defines what is the approach that they want to take towards creating an ML model. Because, right now in the market, you'll see there are many options where you can use AI out of the box. So, there are many vendors who provide APIs. So, you want to do object detection, you don't have to write an object detection model by yourself. You can use APIs, like Google provides an API. I know other vendors also provide. Sorry. Second is if you want to deploy some custom, sorry, I don't need to do that. This part, this is where, this is these auto ML type of products where, you don't want to use an API or you don't want to use a pre-trained model that somebody else has trained. You want to create your own model, but you don't want to do the hands-on, like the actual coding. Because we see that in the world right now, there are a lot of, business users who want to, or the non-tech users who want to make use of ML. There are very few deep learning researchers who, or the data scientists who would tweak algorithms to create custom models. So for those set of users, there are a lot of tools such as AutoML. AutoML is a broad term. Many vendors provide it. Google Cloud provides it. Azure provides it. Data Robot, they provide it. It's where you put in your data and you get an automated ML model. And the third one is where, you want to create, and also this slide will help. Yeah, this is where you are the data scientist cranking out your own model, hyperparameter tuning it, evaluating it. You are doing the entire end-to-end stuff and creating this model. It could be because, either the AutoML models don't satisfy something that you require, or that, you have the expertise and, you want to custom create this model based on your requirements. So what I'm also seeing, there are these major trends in the industry right now. First is the, what I've been talking about so far is the operationalization of ML. Like people have realized that an ML model is great. It's not, you can create a great ML model in your lab, in your research lab, but it's of no use until it's put into production and put into actual use. So this whole process of operationalization of ML has been a great, factor. Like there have been a lot of industries or a lot of vendors who are providing this service to industries. Second, responsible AI. There has been a lot of, you might have heard a lot, there's a lot going on in terms of how can AI be made, more responsible in the sense that it should be ethical, that your models are fair to the customers that they are serving. And also they are explainable, not just to the outside customer, but also to the person who are developing it. Because, as more and more neural networks type of models get developed, it becomes harder to actually understand why a model is making a particular decision. And the third one is convergence. So, previously, data and ML were still treated as two different things. Like you're either a data engineer or a, data analyst. But now, and I know, like, of course, in terms of roles, they're still like that. But what I'm saying is, data and ML are converging in the sense that you can't have data systems in complete isolation with ML systems. You need to have those two together so that, of course, people spend a lot of time and money and energy in consolidating their data assets. How can you bring ML on top right there so that you can do ML right where your data is, rather than, saying, this is where my data is, now I want to do ML, I need to move my data. And then you get into a lot of issues with, well, where is your data? Is it on-prem or is it on a particular cloud? Now you want to do ML in that cloud or in some other cloud. So more and more I'm seeing that industries like the providers, such as Google Cloud or AWS, they're saying, how can analytics and ML be merged so that people get both these services together or seamlessly? That was a little bit about, the state of AI adoption. I'll move on to some challenges that I see in making ML systems more usable, or productionalizing them. So I don't know if you have read, but this that I've quoted here, a hidden technical debt in machine learning, is a great paper this was, I think, by some folks in Google. They mentioned that, and maybe it's not nothing new right now, but if you like, many times it happens that as a data scientist, all I care about is my machine learning model, its accuracy, and how I'm evaluating, and just that. But it's important to understand the big picture. The big picture is that what a data scientist does could be right here, but what needs to put a model into production is this entire picture. And I'm not saying that a data scientist needs to do that. There are other people who do that. There are ML engineers who take care of a lot of this entire pipeline, or data engineers who take care of data management, data collection, feature engineering, those things. But all of these systems together is what creates your production ML system. And I will talk about these modules in detail. But I wanted to present this picture as a, when you think of a production ML model, think of this picture as your, what can you say, as a reference picture. Some challenges that we see, what happens is there are, like, enterprises end up creating, like, there is data engineering team, ML engineering team, and app engineering. So, before production ML models were very common, of course, industries had DevOps type of teams. And the DevOps teams did that. Like, the software developers created their code, and the DevOps team would put that code or that application into production. And they would take care of all the, the process, the CI/CD process, or the testing, or the monitoring, those sort of stuff. With data science, what has happened is, it's not just a piece of software, not just a software code, but also the data. And that both of them together make my model. And that model needs to be put into production. So what we see is, because if teams or if enterprises are using their previous methods, which are DevOps, and they try to retrofit DevOps for MLOps, some things don't get captured properly, and that's what creates friction. So, for example, many times we have seen, like, these are some factors that we have seen in productionalizing ML. One, if teams, like these could be mainly the data science teams who are creating a model and who are trying to push out a model or retrain a model. If they don't have the correct set of practices and tools and process, then they end up doing a lot of manual work. And by manual work, I mean, think of it like, everybody, like, Jupyter notebooks are mostly like preferred, or a preferred way of doing experimentation. But if different teams do their experimentation and modeling in Jupyter notebooks, then that's where a model, you do your experimentation, you end up creating a model. How do you hand that model or that piece of code to the team that will actually, your DevOps team or your MLOps team, they'll put it into production? Do you have an automated way to do that? If not, like many times when people don't, they end up manually sending those Jupyter notebooks to the other teams, to DevOps. And this sort of manual work leads to, well, one, it leads to less efficiency and introduces more chances where there can be errors. Second is, because wherever there is a lot of manual work, it means that you don't have reproducible and repeatable assets that you can, that you can use. So with some of the tools that I'm going to talk about later, as part of best practices, for example, like pipelines. So with pipelines, you end up creating reproducible modular components that can be used maybe not just by your team, but even other teams in your organization. handoff, and I already talked about handoff between data scientists and IT. So, is there a process so that this handoff between once the data scientist has, given a stamp of approval for the model, like it has been continuously experimented and evaluated on, can it now be handed off to IT for final deployment? What does that process look like? So there are a lot of these all these steps are where so many artifacts get created. Previously we had the app, so there was like maybe like that module or that jar file that you have to put into production. Now you have a particular model with certain features which are also engineered, which were based on some input data. There is a lot of artifacts that get created whenever a single ML model is generated. There is you have the model artifact, you have your training data, like you need to keep a track of what was the training data that you trained this particular model on. So all of these, there is so much what do you say, a metadata and artifacts that are created that make this entire process very challenging to keep it running like a well-oiled machine. And the bigger the organization is, the more these problems come in. And not to mention the fact that you're not like a sorry, did I have a question? Okay. The more so with this slide, what I wanted to show is, of course, there is like data and tools that you need, but then an enterprise is also consists of the people, the different processes that they have put in place, not just technical, but also how things get done in a particular organization, how new ideas flow. Somebody says, for this particular model, I want to create an ML model. How does that entire thing look? So I just wanted to point out here that this whole combination of people, technology, process, and data also makes ML adoption in an industry. So an industry, a company that hasn't yet adopted AI, when they start adopting AI, all these factors need to work together. And I will quote there was a white paper from Google. If your company is in those starting lines, like, where your management understands they need to do data science and ML, but don't know how to. This paper actually showcases a great framework on how to adopt AI. Great. So with that, I talked. Now I wanted to focus on what are the best practices for production ML systems. So mainly, and again, I'm quoting another Google white paper that Google had published for a practitioner's guide to MLOps. And this paper has a lot more details, and I have taken out some best practices from this paper to discuss with you today. So how the MLOps processes interact with each other, focuses, and this diagram shows a high-level flow of what are the different stages and what are the key inputs and outputs. And it will look like a step-by-step process, which it is. It's not a waterfall process. What I mean is, it's not that once ML development is done, you do training operationalization, this step 2. It doesn't mean that you don't go back to ML development. Don't think of it in that manner. These steps frequently we go front and back, mainly because data science is very experimental in nature. You have to frequently experiment or retrain a model. But this diagram is supposed to show what are the 7 major or six major stages in ML creation and deployment. And of course, the 7th part here is this is horizontal. This is how do companies manage their data and model and features. And what I showed earlier was a 6-step process or stages. In order to put that process into reality, these are the technical capabilities that you need. So any company like who wants to put a model into production needs these technical capabilities, like some tools to do experimentation, some tools to do data processing or training of a model or evaluation of a model. So these are technical capabilities. And then there are some, again, tools that are required for throughout this process, such as repositories where you can save artifacts, your model, your data set, and your features. Things like, security and privacy. So at every step, especially this becomes all the more, important and a cause of concern for companies when all these steps are taking place not on-prem but in cloud. So very often we hear concerns, not very often, all the time, I hear concerns about, from companies, they ask if my data is stored in the cloud or training is happening in the cloud or whatever that is happening in cloud, how is my data and my models being secured? And we tell them about, the security and privacy tools that are available in Google Cloud. So you might have heard of, virtual private cloud or access control. Those are some tools to do security and privacy. So these are all horizontal, and of course infrastructure. That do you have the infrastructure, the compute machines where you will run the training or the evaluation, or if you're doing some deep learning models, you want to use accelerators like GPUs or CPUs. Do you have them available? That's infrastructure. I'll stop here for a quick minute just to check in that before I dive into, so what I will do next is I will dive into each of these steps to talk about them in a little bit more detail. But I wanted to check in to see if there are any questions I can answer.
Benazir, I think there's one question from Nandini, if you can see. What is your opinion on automatic retraining of model after deployment from time to time to keep up with the data drift?
Yeah, great question. And it depends on the use case. So there could be a use case where like if you are doing object detection, if you're creating an object detection algorithm for, I don't know, let's say flower object detection, then the species of flowers don't change very much. So maybe you don't have to retrain your model very often. But oh sorry, you did talk about data drift in particular. So yes, absolutely. So if your use case is where you will see a lot of data drift, one, you will have to monitor that data drift. So there are, do you know the tools and the technique to monitor whether your, this training data that's coming in, I'm sorry, not training data, prediction data that's coming in, is there drift in your prediction data? And then you need to identify what is the threshold that, of course, prediction data will have some drift. What is the threshold after which you will say, if my drift, crosses this particular threshold, my model should be retrained. These are the things that will depend on, your use case and how sensitive you want to be with respect to, training new models with data drift. Once you do that, then, let's say you've identified these two things and you say, at this point, I will want retraining. Now, in order to, I know you mentioned automatic retraining. So I will, in my coming slides, I will talk about places where, if you operationalize your training such that, you have a pipeline which you have created that can do automatic training of a model. Then whenever you say your threshold has been met, you can set triggers such that whenever the threshold is met, you restart that training pipeline. So the training pipeline will take new data and retrain a model. So, and then, of course, once you retrain, you evaluate it and it meets your whatever evaluation criteria is, you can put it into production. Does that answer your question, or you were looking at or you were wanting to ask about something in particular?
Feel free to turn on your mics and respond. I think that was
I think you answered it. Thank you very much.
yeah, it was well explained.
Awesome. And in one of the future slides, I will again show you what that entire process looks like. Okay, great. Okay. So the first step in this entire process is ML development process. And that's where, of course, as data scientist, you will spend majority of your time, because there will be a lot of experimentation that you'll do, experimentation and prototyping to fine tune your model, to make your model better. And that's where this is supposed to show. So what we suggest as part of best practices that like if you're doing large, like not by large scale ML, I mean there are a lot of models like that are being experimented on, or that are in the pipeline for production. You should have, or your enterprise should have these type of tools, like a repository to save your data sets and features. And that's where data set repository is where the data engineering team, after they do their ETLs and clean up the data, they save their data sets here. So as a data scientist, you take your input from these repos, the data set repos. As part of your ML model, whatever features you're creating, you should store them in feature repository, so that one, not just you and your team, but other teams in your organization can benefit from these features that you have created, and vice versa. Like maybe you don't have to reinvent the wheel for a particular feature. Maybe somebody in your organization has created a feature already, and you can just reuse it from that feature repo. Once you create a trained model, it should be stored in a model registry, so that we all know that like for example, this question that Nandini just asked, if there are frequent retrainings of models, then you need to have some way to identify that from one, for audit purposes, and also for your own explainability purposes, that for the month of January we were using this particular model with this particular version, and this is how it was trained on, tested on. For the period from February to March, this was the model that was using. So if there is a registry of model, then it makes this whole process of model governance very easy. Metadata and artifact. So we all know that model is not the only artifact that gets created. There are many other artifacts. So like in the next step, I'll talk about training pipeline. Training pipeline. So I don't know if, like, I mostly use Kubeflow pipelines. Kubeflow pipelines end up, when you create your training pipeline, it ends up creating a JSON file as a pipeline artifact. So that is an artifact that must be stored in some sort of repository, so that one, you can reuse it, and if somebody in your company wants to reuse, it's good for them. Once you create and you're happy with your model, that particular code, the source code for that model, or and how you have done evaluation and all that code, and configuration. By configuration, we mean here that what was, for example, for a particular model, what were the hyperparameter tuning parameters that you finally that end up giving you the best model. Or configuration also in terms of that you took this particular feature or this particular data set from the data set repository, those things. The next step is the first step was the model development process. Once you have developed a model after all the experimentation, and you have a winning model, what next? This step is saying that once you have the model, create that process where you can create that pipeline. So this is the training operationalization. You are operationalizing training specifically for places where you will retrain the model. So in this case, you build and test an ML training pipeline, and deploy it to a target execution environment. So in the continuous integration stage, your source code is unit tested, and you build a training pipeline. And this training pipeline, I think this is the third step. This talks about the training. So when I say training pipeline, these pipelines are composed of these modules. So each of these modules is doing a particular step for that in that process, like data ingestion or data validation, then data transformation. Finally, it's your model training. This is the part where whatever your that winning model is, you put that particular container here. Evaluate that model, validate it, and then put it into the registry or deploy it into your system. So this is the pipeline that I'm talking about. So, and this pipeline, and Nandini, yes. What I was talking about is this is the retraining trigger. So, if you have a pipeline, and then you've identified at what point you want to, you monitor data drift, what point you want to train it again. If you have a retraining trigger, that could trigger this training pipeline again. It will take new data and new features. I don't mean new features, I mean new feature values and new data set, and retrain your pipeline. And then, follow on the process of putting it into production. Yeah. Model deployment. So this is the fourth step. Like after you have created your model, you have gotten a process to operationalize it, such that you are doing your CI/CD process, putting those artifacts into repositories. And then the fourth process is this, which is model deployment. So here you are saying, your final model can be packaged, tested, and deployed to your target environment. So what I mean here is, in the CI stage of model deployment, like you are saying, you have created a model. Can you test your model interface to see that it accepts the expected input format? And that it produces, so it takes input in a particular format correctly. It produces output in a particular format, so that whatever is your downstream system, like your model is supposed to predict something, and then it's supposed to give that output to some downstream application to finally either show it to the customer or feed it into another model. Is that in the correct format? You validate the compatibility of the model with target infrastructure. That maybe your model, when it's doing prediction, it needs a particular accelerator. Does your target prediction environment have those accelerators available? Latency. You also check whether the model is serving outputs at the latency that is desired by your overall application. And again, here there are all these different tools, such as model registry, artifact repository. There is the model serving engine, and there are, depending on the framework of the model that you have, you may choose different types of prediction servers. The next step in this process is prediction serving. So at this point, you have tested and packaged your model, and now it's finally in you're actually doing prediction with it. Now, at the time that you're like doing prediction, can you this prediction can happen in many formats. Like you could do online inference, or where you are looking at real time, that your model should be able to serve results in real time, or batch inference, where your real time is not a requirement, and you're batching requests together, and then asking your model in a batch inference format, and the model responds with those batch responses that you can then further process and serve to your downstream application. Yeah, and that's where some other things like your model monitoring engine will be here, such that whatever serving you're doing, you're also storing some serving logs in cases of where you want to go back to identifying why, if something were to go wrong in prediction, what happened. And also when you are serving this model, you're getting the serving data from the, now here this is model consumer. This could be either a downstream model or some application. It's giving you serving data. What you're giving it, your model is giving it, is the predictions and also some explanations. So more and more, especially in certain industries such as healthcare and finance and government, public sector, there's more and more a need of explaining not just your model, but also each and every prediction. So, why did your model make a particular, like for this particular serving data, which was, let's say one, for example, that a particular person's loan application. So you got that particular person's data, your model made some decision, which was a loan accept or loan deny prediction. Why? What were the major features that were given most importance when you made this particular prediction? And the last one is continuous monitoring. So, the world around us is changing all the time. You cannot expect to have a model that, of course, you spend a lot of time tuning. You can't expect that model to always behave perfectly, mainly because the world around us is completely changing. Consumer patterns, data patterns are continuously changing. So you need to monitor your model. So these are the best practices or the set of tools that you need in order to monitor how your model is doing. Now there are two things. One is of course the infrastructure part or the logistics part, which is is your model giving you the latency of the model, or that the model needs to run on a particular prediction server. How is that infrastructure running? It's one is that kind of monitoring. The other is identifying whether if you're noticing any data drift, any prediction data drift or concept drift, where the relationship between your target variable and your input data, are they still the same as when you first started training? You identified that there was a particular relationship. Does that relationship still hold, or has it drifted? So you do these, and of course, if this monitoring, if you identify that something is gone awry, then there is an alerting mechanism. So this alerting mechanism will tie back to these. The alerting mechanism should, what's missing here is it'll alert, for example, some people, like in your monitoring team, for example, your ML ops team, it should alert people either through email or text or through logs, whatever is the process, that this particular model has decayed. And then that should lead to a trigger here to retrain that model. Okay, great. And the last one that I wanted to touch on is the horizontal process that should, it has proven to reduce the number of the number of manual steps that people end up taking. For example, so how do you manage your model and your data set? So do you have data set and feature repository with the functionality that you might need? You probably just do batch serving, or do you do online serving? If you do online serving, your feature repository should have the ability to serve features at real time. And then things like data set one more thing about feature repository, that you are creating and registering features that you feel will be useful to other people in your organization. And data set repository has these tools built in, which is that you can identify lineage of your data. that, there was a particular training data set that was used for a particular model, but now that you're retraining, that you are consuming a new set of data. It won't be of any use if you retrained on an existing data set. So your data set repositories is a place where you can you're continuously versioning data sets, because new data is coming from your the systems that precede this, which is the data engineering systems. Okay, great. One thing I wanted to touch on is explainable AI is also, there are, especially in recent times, a lot more regulations, and also with the increase in use of a lot more neural networks, where it's not, or large scale models, it becomes increasingly hard to understand how a model is behaving or why it's serving a particular prediction. So the ability to explain models, and there are several tools, depending on your use case, that you can use to explain your model or explain why it made a particular prediction. And this part, the ML explainability, it fits. I mean, it should happen at every stage of the MLOps process, like right from when you gather data. And so, you identify that you are going to make a particular, you have a particular business problem and you want to, answer a part. Let's say it's a classification issue. You want to, for example, this loan example that I gave earlier. You want to create a model to accept or deny loan applications to people. Right from the point where you say, what will be my training data? The explainability or the fairness should be part of your consideration right from that point, to identify what would be your data set. How would you identify if that data set, fairly covers the population that you're going to serve? Right to, after you train a model, can you ensure that, your model, based on how it is evaluated, that it will serve fair predictions to the population, or the population from which the prediction traffic is coming to this model. Finally, when you deploy the model, you ensure that, through monitoring mechanisms, that it's working properly on real data. You make prediction, and how you actually surface those prediction analysis, that you enable the end user to make sense of the prediction that you made. So there are some, feature importance, or which feature was influential or most weighted on in making a particular prediction, that it's transparent to your end user. I know we are already at 50 minutes, and if there are any questions, I would love to take the questions before, and then I'll move on to a short section which I had for roles in AI organization.
Any questions for Benazir? As you can see, there's a lot more to than just doing a Y predict, model.predict, right? There's just so many other aspects to it. So yeah, thank you for taking us to this fantastic overview of, what are the components that are connected to the model in every aspect, right? Upstream, downstream, and then what you're going to, what is required actually. And each of these comes with their own tools and practices and so on. So there's so much more to it than just creating a model. So yeah, thanks for that awareness.
Yes, yeah, thanks. And I don't mean to say, like, I know this is a Women in Data Science forum, so maybe most of you are data scientists. So I do want to stress that everything that I showed here, it's not that a data scientist is responsible to do all this. No, I don't want to give that impression. As a data scientist, mostly our responsibility is in the very first step, where you are creating a model. But you need to know how, it's good to be aware of how this entire journey takes place. And some of the tools that you are used throughout the steps, like feature repository, for example. A feature repository can make a data scientist's life very, very simpler, like not, I won't say simpler, a lot, but I mean, there are so many other factors that you need to take into consideration, but it can make the feature engineering part a little bit simpler. If you identified that there is a feature repository in your enterprise, and maybe somebody else has spent enormous amount of time creating a feature that you needed, so you don't have to spend that time. You can reuse that feature. So that's why I wanted to, with all these systems, I wanted to say, all these steps, I wanted to showcase what are the best practices for this end-to-end process. And so in the 5 minutes that I have, I do want to quickly touch on roles in an AI organization. So I know many of these roles we already know about, like who is a data engineer, ML engineer, data scientist. So I won't spend a lot of time on these, but I wanted to say, other things. For example, many times I see that people have a lot of knowledge in a particular domain. They were working on that particular domain for years. They know how that domain works. Now they want to move into an AI related role. It's not necessary that everybody has to learn how a particular algorithm works, or how to do ML modeling. No, if you understand what is the value that AI provides and you combine it with your existing domain experience, you can also get into other type of roles. For example, like a product manager. So there are roles in AI organizations such as a product manager. They don't have to be data scientists. I mean, it's of course, they definitely should have an understanding of what an ML model is doing and what are the inputs to it, and how to create a trustworthy ML product. But they don't need to know the math or the statistics behind a particular model. So product manager, solutions engineer, these are people, like I just mentioned, that if you have a great knowledge in a particular domain, say insurance, for example, or manufacturing, and now you want to get into ML, solution engineers, and I've seen this role in many companies, through which you can even combine these two, ML and domain experience, and become a solution engineer for a particular industry. AI ethics officer, there is a growing need for making the ML systems and the ML products fair and ethical. So if that is of interest to you, AI ethics officer, or there's a lot of research. It's still a nascent area. So if you are interested in that, these are also roles that you can look into. And I will spend business analyst again, is another place where, like I mentioned, that ML and data are merging together. So if you were a data person, if you are a business analyst, chances are the numbers behind how your business operates. What you need to learn, maybe, and again I will say maybe, is maybe you need to learn a layer of how to use ML. And that's where some of the in a previous slide where I showed that somebody wants to create an ML model, it's not that they have to be data scientists and start writing code in Jupyter Notebook. You can use tools such as AutoML or pre-trained ML APIs, or in business, for example, Google's product, which is BigQuery, which a lot of business analysts use, and they write SQL queries. Using that exact same interface, using BQ machine learning, you can do machine learning on that data. So if you're a data analyst, you can learn that skill of how to do BQML. Again, it's in SQL. But if you understand how to do that, that's another role in AI organizations. So you're not just business analyst, you'd be like AI business analyst or whatever. But you can become that in an AI organization. Great. Well, that's all I had. I see one more question. So the question is, in XAI, we check whether the model has certain bias towards some features or not. So how do we deal with the situation when we do find the bias? we manipulate the training data set or build business rules on top of it. I would say, like this process starts when you say from the business side, you say you want to solve a problem. And once you define that problem, then you create your training data that you'll train your model on. But then if you say that your model has a particular bias, again, you can, come back to like you said, that you can change your training data set so that you include more, maybe your model was unfair towards a particular, let's say a particular section of the population. Maybe you should come back to your training data set and change. I mean, if you don't want to change your business problem is still the same. Come back and add more examples of the population that was, biased towards in your training data set, so that your training data set has enough examples. Because after all, a model is, what is a model? It's an automated way to learn from your data. So if your data has all these, it's representing everything correctly, maybe that's the first step that you need to do. But if you want to say that this is the training data set and for some reason you can't change it or you don't have more examples, that's when you probably need to go a step behind and say, change your business problem, or the problem statement. So instead of saying that this model that we're going to create is going to serve the entire population, now that you find that your model, because of the training data set, has a certain bias, maybe the initial thing, the problem statement, then needs to change. That this particular, given the constraints in this particular training data set, this model is only going to be used for populations who are for whom the model was fair. But now it's hard to, you of course want to solve the main problem. You can change your problem statement, but then you're just clarifying that it will solve this part of the problem. But how will you solve the entire problem? So because that entire problem still needs to be solved. That definitely you'll need more training data or better training data to train that model. I don't know if that makes sense. Sorry, I think I explained it to myself, but I don't know if I was clearly able to explain it to you. Okay, awesome. Great. Well, thank you so much, everyone. And thank you so much, Nishreen and team for inviting me. A quick plug here, Google Cloud is hiring. So if you want to apply, please get in touch with me. I would love to, answer any questions that you have. And related to the presentation that I made, if you have any questions, I would love to, please connect with me on LinkedIn, or, you can also get my email from Nishreen. I would love to answer any more questions.
Absolutely. Benazir, I think the audience was also asking if you can share your slides. If you can share it with me, I'm going to have it on the YouTube page with the recording so that they can access it from there. And of course, that's up to you. While the speaker decided they want to share the slides.
Okay. Yeah, sounds good. I'll just have to check internally with my company policies, sure. But I'll check and I can then email you.
Okay, sounds good. Thank you so much. Thank you for that fantastic presentation. I think, bringing that awareness is key, because we all have to work with other people upstream and downstream. So making everybody's lives easier is key to getting these models into production and having success with your machine learning approach. So thank you for that. I think, yeah, we can stop sharing. I have my next speaker also. So we are going to have a little bit of a change. Rosanna could not make it to the talk, but so instead we have the next speaker joining earlier. And I'd like to introduce our next speaker to you all. And I think she can, while she gets started, I'm going to introduce her. Dr. Kulsoom Abdullah is a data scientist with Anthem with more than 7 years of experience in data science and machine learning and previous experience in network security data visualizations. She's currently working for a healthcare insurance company. Previously, she was in malware and human resources domains. She attended the University of Central Florida and received her doctorate in electrical and computer engineering at Georgia Tech. And she is keen on all things data. She's an enthusiast, and I've worked with her. And her interests are in applied machine learning and deep learning research and AI for good. So with that, I will let Kulsoom take the stage and begin her presentation.
Hi, everybody. Thanks for having me here. So this talk will be about majority recurrent neural networks and LSTM, so general fundamentals about them. And then I'll be talking about briefly just 2 applications in climate change that you can use them with. I just wanted to give one disclaimer that that something like deep learning wouldn't be the first thing you would want to try. You'd want to try first maybe a baseline or a shallow machine learning technique such as support vector machines or logistic regression for classification or linear regression for a regression problem task. Okay, so a little about me. Nasreen already told you some things, but and it's pretty much the same what I have here on the slide. One additional item is that I am a weightlifter. That's my, I guess you say, my second identity. I won't go into the story about it, but I basically do it, and I ended up causing some change with it, and I still like to do this for my my training and just my my physical health, mental health, and I might think about competing again. Okay, so this talk will talk about recurrent neural networks, and then the long short-term memory, which is usually a better option than using RNN, but I'll talk about the RNN because there's a lot of overlap with the fundamentals of that to the modification using long short-term memory. And then the 2 climate applications I'll just briefly discuss is one paper that used it to predict energy consumption in a building, and then a second one that used it to predict rainfall runoff. Okay, so to start with, recurrent neural networks, the difference between these and say your traditional deep learning, which you'll see in the first on the very left, the one-to-one. So with that, with deep learning, you'll have an input, and then you'll have something in the middle to some architecture to process it. Like it'll go through a series of weights and biases and activation functions, and if it's a convolution network, you'll have a convolution layer, a global pooling, etc. And then output will be one, either one item, which would be the classification of that model prediction, or maybe some numerical value. So with recurrent neural networks, that's going to be what's everything on the right, the one-to-many, the many-to-one, the many-to-many, and the many-to-many, which just means that you have the option of saying, I want to have one input, but I want to be able to predict multiple outputs versus multiple inputs to one output, etc., or have many inputs and then many outputs. So some of the examples of these would be something like image captioning, where you'd give one image, but you would have more than one output, which would be a sentence or phrase that describes what's in the image. Then the many-to-one could be, say, you're trying to classify multiple video frames into one item, like what's going on in the video. And then many-to-many would be something like translation of a language where you'd have some phrase, it could be some mixed number, and then your output would be the translation of the phrase, which would be some multiple answers. Okay. So briefly with RNN, the idea is that now instead in the middle, what you have is an internal state. And each time, as you can see on the right, this would be what's called unrolled, is that you'll have an input. It goes into what is going to, well, I'll describe as the RNN, and then it gives an output. Now there's something called a state that comes out of this RNN that goes to the next one. So that information goes to the next one, plus your second input. That together can give you another output. So that's the rough idea with this RNN. Now to go into what this is, what the actual green box is again, it's where you're going to have some old state. So if you look at the picture at the right, the unrolled one, that might be easier to understand, that first X1 is going to be your very first input in your sequence that you would be putting in. H is what they're called a hidden state. So initially, you'll have those two coming in to the green box, and that's going to calculate two things. It's going to calculate a Y1, or here YT generally, and then it's also going to output this hidden state, which is the H. And so this is going to keep repeating until you get your input processed or you get the number of outputs that you're expecting, or that the deep learning network is going to output for you. So the basic RNN here, let's say you have one input, it goes into the RNN here. These are the detailed equations. So the hidden state is calculated for the present time, and that's going to take your input matrix, and then also whatever was happening previously, this HT minus 1. So briefly to mention here, the tanh, and if you're familiar with activation functions with deep learning, which if you're not, that's fine. But there's several activation function options that you have for deep learning. And so one of them is called the tanh. And so what I wanted to address quickly here was that ReLU is one of another activation function, and that's traditionally used most of the time, or that's the default that you would use in deep learning. But for a LSTM and RNN, the tanh is used instead. So I have some information on that if you'd like to dig deeper into why. But in spite of that, there is some work going on of being able to use the ReLU. Okay, so just to step through how this could be set up or run, is that you have your first input. Your hidden state could be just initially set to 0. Then you put the input, your hidden state, mentioning input, your function then calculates this box. And again, just to verify, if I mentioned this earlier, that when you train your network, the weights that you learn for this RNN, they're going to be the same weights that you're going to apply for every time step. And they will be used to calculate your current hidden state and current output. And you'll just keep looping and repeating this. And so that's what this picture here is showing, is that the W is your weights that you've learned. And the same weights are going to be applied every time to keep calculating this next hidden state and output. Okay, this is showing you the same thing, except the other thing you'll be learning now here is that every time that you have a output, And as you're training, you're going to have a loss function. So similarly, how when you have a deep learning network, whatever output you get, you're using some kind of a loss function metric to see how well did the network predict this output compared to what the actual answer really is. So in the case of the recurrent, where you're going to have more than one, or most likely more than one output, you'll have many losses. And so those are going to be aggregated together as your total loss for this input and output. And then here, similarly, if you only are expecting one output for multiple inputs, it would be the same thing, except you would only be having one output and one, say, loss. And again, just to show you all the different examples, it's the same concept, but just showing you that if you have the one input versus the multiple outputs, it's the same idea. Okay, this is something where, say you have like the language translation example, the sequence to sequence is where you could have a variety of inputs. I mean, you won't. When I say variety, it means that you don't know, or you don't have a fixed input size, right? So say where you have a sentence that you want to translate, you could have various sizes of sentences or words in it. And then with the corresponding translation, you could have a mixed size coming out of what the actual translated words are going to be, because they're not going to be necessarily the same number of outputs that you do as your input. So that's what this term is talking about. All right, then for the actual learning of being able to learn what are the best weights for your neural network, in deep learning, you use a concept called backpropagation. So with the recurrent neural network, when you have many sequences going on, or this rolling going on, it's not where you just have in the deep learning traditional network, you have the input, it goes through once through your network, and you get your output, and you just go back and forth between the input and output to, figure out what was the loss, update the weights, and etc. So the challenge with the recurrent neural network is you could have a lot of sequences going on for the input, and you have to trace back the steps to be able to figure out what weights to update. I mean, how to update the weights. I know there's a lot going on here. So the problem with this is that as you keep multiplying to update weights, it could take a long time. You might not have enough memory to keep all of this data. Every time you keep calculating, you have to keep track of all of the weights that you've been coming up with. So another idea is to use something called truncated backpropagation through time, which the idea is to say, do it for some number of steps, then stop, update the weights, calculate your loss, then you can move on to another chunk. And then this way you don't have to save every single weight step. And that seems to work pretty well in the field. All right, so now this picture here, it's showing you what we've talked about before with RNN, but the next slide will then introduce you to what the LSTM is. But first here with the RNN, the traditional one, is what I talked about here, that you're going to have an input coming in, and you'll have a previous hidden state. Those are put together and multiplied by this weight matrix. And then the tan-H is the activation function that's applied to those, the sum of those two weights multiplied by each respective variable. And then that's here in this slide, what it's just showing you what the ultimate representation is after you expand out the operation. All right, so the next one is showing you this now in the unrolled fashion, that how it flows through, as in when you calculate, you have your first input and you get your hidden state, then you go to your next input, you know, repeat the same operation until you process all of your inputs and you get your outputs. So the problem with this is that because you're doing many multiplications of this weight matrix, and it's going to be the same one, that if your that weight values are either greater than 1 or less than 1, you're going to have one of two problems. So with greater than 1, the compounding multiplication, you're going to get this exploding gradient. And so what that means is it's going to become such a large number that your computer can't even represent it anymore, and you're going to stop learning, meaning it's going to just stop updating the weights because it can't, it just keeps growing and the number can't be represented. And then somewhat similarly, if your weights are less than 1 and you keep multiplying, they're going to become smaller and smaller, that they're just going to go to 0, and you cannot learn anymore either. So the one of the other ways to try to deal with this is they came up with was just to do a different architecture for RNN. And that's where the LSTM comes from, the long short-term memory. So it is the same idea as I've been going over with the RNN, except now you have some extra variables here. So instead of just a hidden state and an output, you have 4 more variables that you're calculating. So I'll go over those in the next slide. So this is showing you how this happens in this RNN unit and the multiplication and the reasons for it. But basically, I, which is your input gate, this is a value that's calculated to determine, do you want to keep the information in this cell? The forget is if you want to erase it. The output is like, how much of it do you want to keep? And then gate, I think there isn't actually a proper term for it. That's why there's this question mark in the slide, but that how much do you want to write? So the purpose of this is so that you can deal with the problem of the vanishing and exploding gradients. But even if you have a very long sequence, this will help you to retain information and for your network to learn. So this is an unnecessarily complicated looking plot, but it's showing you the layout of the calculations. So compared to the RNN, where we had the XT and the HT minus 1, the previous hidden state to the current state, added and multiplied by weights, and the output was another current hidden state. So this time, with the addition of all of these other outputs, this is showing you how all of that comes together and it's calculated. So now the advantage of this too, here you can see in more detail at the top, is when you're doing the back propagation, you don't have to multiply by the weight matrix anymore. And you're only looking at, or you're only doing an addition and an element-wise multiplication by the cell, the gate. And this allows you, as you go back in time, to not lose information and have the gradient problem. So this is the picture of that I described in the previous slide, of how you can go through with back propagation through these multiple sequences. And in traditional deep learning, specifically with convolutional neural networks, this idea is similar to what's applied in an architecture called ResNet, which is used for classifying what's in an image. And so they have these skip connections to help preserve information after these calculations could erase or possibly erase or explode the gradient values. There are some other variants of this. So another popular one is called gated recurrent unit, GRU. And there's many out there in papers, but generally the LSTM is fine. And if you were going to try out using recurrent neural networks, usually LSTM would be the first one you'd want to try. And if, depending on your problem in the domain, you might or might not want to experiment with other ones out there, or tweak the one that you're using now. So in summary about RNNs is that compared to, say, the traditional deep learning network, there's a lot of room for flexibility on how you can design your inputs and your outputs. And it's great for either time sequence or data, that keeping it in that order is important. And we mentioned that regular RNNs, they're the simplest ones, but they don't work due to these gradient problems. So generally using LSTM, or secondly, the GRU, are going to be better for you in that regard. So then with the dealing with this exploding and vanishing gradient is using vanishing, we said use the different architecture, the LSTM. And exploding gradients, you could still use an RNN and clip the gradients so that they don't get too large. But again, I'd say probably want to go with the LSTM. And then finally, you mentioned that there's a lot of other architectures, and there's not much research done with this to know what would be best to use. So there's still a lot of room for research and experimentation. Okay, so I'll briefly mention the two climate applications. See, so for the first one, there's a paper that used LSTMs for coming up with a model to predict how much energy or kilowatt hours the HVAC, or the heating, ventilation, and air conditioning of a building would consume. And the paper goes into more detail about why that would be useful or helpful in the domain. So I won't go so much into that, but I would encourage you to read the paper if that's of interest. But I know a lot of you with the domain knowledge will know why this is a very helpful thing. And so they mentioned this paper too, and also tried your other shallow machine learning methods like support vector machines, random forests, and such to or regression random forest, I mean, to come up with a model that would predict energy consumption. And while those generally worked well, in their case, they decided to try the LSTM because there was so much data and complexity in it that they were getting from these sensors. And one of the advantages too is that it could deal with a lot of the time lags they had. And the deep learning could handle that if they had the time lags missing in the inputs. And the LSTM itself could learn the important features, as opposed to when you use the shallow machine learning methods, you might have to do more data processing. And so in this case, they also mentioned that because the data that they were getting from these sensors were on many different scales, the one data processing they did do was to normalize the data, which was to center all of the data to have a mean of 0 and a standard deviation of 1, so that all of the features would be on the same scale that were coming in, and that it would be easier for the network to learn the weights. And then the second final example that I'll give is the one for rainfall runoff. So there's more domain knowledge in here, but in this paper, but from reading it, I can briefly explain is that they wanted to be able to predict how much water would be coming out of these basins. And they had data, a lot of data for one of them, which was about 15 years of daily data. And they wanted to see, could this do better than the baseline hydrological model that was being used to predict this, the rainfall runoff. And so when they tried this or used the LSTM on the 15 years of data to predict, they did very well. And the other thing they did was for other basins where they didn't have as much data, and because of not having much data, they weren't able to use LSTM, but they went ahead and used the model that they came up with and trained on the 15 years of daily data, and then used transfer learning on the other basins with less data, and they also had pretty good results. And this picture, which, actually this picture will be better. They show in the paper, and this was also in the previous paper, was that how you would take your data that you, like say in this case, the 15 years of daily data, and set it up for training. So what they did is they took batches of it over time. So like saying, let's say you have your 15 years, right? You could say, I'm going to just take the first month as my input, and then whatever happened the day after that month is going to be the output. And then they keep sliding this window to have a train, a input and then an output value. And they'd use all of this to help to train to come up with the best weight matrix. So, and then they said, a disadvantage of using LSTM and deep learning in general, in addition to needing a lot of data, is that they're harder to interpret than using traditional machine learning models. Okay, these are some of the references I had in the slides. So if you'd like to look further into LSTMs and generally about RNNs, and then I have links to the last two papers. Okay, that is all I have. I know that was a lot of information. So if you have any questions, whether it's related to this or not, or any comments, please feel free to share those.
Please feel free to share any questions in the chat, or open up your mics and ask them directly. Thanks, Kulsoom. I mean, those were very complex algorithms, and you took them, you took us through with simplicity through them. So, that kind of homes in on what the idea is behind the algorithms, right? So thanks for that. Yeah, please if you have any questions, go ahead. So do you generally recommend LSTMs for only time bound problems, or can they be applied to others as well?
So generally, if there's let's say with NLP, right? Like say a translation. So in that case, if you're wanting to say translate a sentence, the LSTM or the RNN would be helpful because you can input your data as a sequence in that order, and that information is something helpful for the prediction. So that would be, I guess, anytime where the sequence of the ordering of your data is important, or at least it's going to be helpful for a better prediction.
Okay, got it. So any kind, it could be a time sequence, or it could be a sequence of information coming in. So anything that's more in sequence, these algorithms generally do better.
Yes. Or at least they, yeah, depend. I mean, I would say still try to do a baseline or something really simple first.
Mm-hmm.
That way you can be certain that going the LSTM route or the deep learning route is worth it, that you do get better results.
Yeah, I know you mentioned earlier also, go start, try something simpler first, like random forest regressions, and then go to SVMs and then LSTMs. It depends on what kind of accuracy you're looking for. Definitely some of these complex algorithms give you more accuracy, but then they are harder to interpret, and you need lots of data and resources, right, to run them. So you have to balance and keep all of that in mind when you approach a problem. So. Any other questions for Kulsoom? And generally all audience and she has shared her presentation, so we will be posting the presentation along with the recording on our YouTube channel, and everybody will get a link for that, so we have everything in place. All right, so we have about 20 minutes until the next speaker. So I'm going to, everybody can have a break, or you can hang out here and network and chat with each other. Tell us where you're from. Are you all? So yes, we are waiting for your talk. I was telling them how fascinating it's going to be and your journey. I was sharing your journey with them, but I will officially announce now that you are here about a little bit about Amy and her background. Is that she was diagnosed with a rare stage 4 cancer in the prime of her life, and how music and dance has helped her recover and inspired her to launch her own company, which is Dance for Healing, and it's an award-winning behavioral telehealth social venture. And she also has other things going on, which is a stage 4 media network, which is a global media network for others who are facing hardship. So amazing work, Amy. She's also a UX and behavior strategy expert in innovation and AI for international brands like Yahoo, AT&T, VW with Volkswagen, and Sony. Her work has been featured in the New York Times, NBC, Yahoo, Gizmodo. She's a graduate of Singularity University and a board member of Humanity Plus, which is a nonprofit known as a global think tank in AI, robotics, longevity, biohacking, and life extension. And her nonprofit work has been mentioned by Time Magazine and featured in major Chinese media. Welcome, Amy Lee. We are excited to have you here and see what you have to talk to us about. I think you should be able to share a screen.
Yeah, sorry, I apologize. They're trying to deal with the last minute PowerPoint with video.
No problem.
Was not easy. But I promise you, there's some movie clip that including in the PowerPoint that finally work. It's gonna be fun and engaging. Okay. And I also invited my advisor, Linda, because I have a section specific on ethics. And Linda is an expert in ethics. So she would chime in at that part as well. Okay, so let me share my screen. And let me know if you could see it. Are you able to see it?
Yes, ma'am. Yes, Amy.
Okay, I gotta move the sky away. And thank you so much, everybody. Thank you for being with us on Saturday. which you could go out and hiking or have fun and come here and to listen to the boring AI talks. All right. Good to see you guys. So the topic today is hacking health in humanity with art and human-centered AI. Oops, let me see if this works. All right, oops. Yeah, okay, so I know many of you probably have aging parents or grandparents or like, friends or family that dealing with difficult disease and you wanted to support them, you don't know how. I empathize with your pain because I went from 1 year as a marathon runner to another year fighting stage 4 cancer. Luckily, my mom was there as my caregiver, and she really empowered me to understand how difficult it is to care for your loved ones. And this is why I decided to dedicate my life to helping patients like me and also elderly like my mom. Yeah, and this is actually right before I go into chemo. You see that I have long hair before cancer, and even just cutting my hair off in the salon when the first string of hair putting on my palms, I was broke down in tears. And luckily I was surrounded by such a supportive community at Singularity University at the time. So this is actually the boat party where the professor actually took a photo of me and my mom, my bright smile before I go into this long year battle. So who is Amy Lee? I call myself a design nerd and a patient entrepreneur and a futurist. So I founded Dance for Healing after my cancer, and I also started Stage 4 Wisdom Media Network. In addition to that, I also on the board of directors of Humanity Plus, which is one of the oldest futurist nonprofit that known for AI, robotics, biohacking, and longevity. And of course, after my cancer, I become a patient advocate, and I bring my extensive background in human-centered design and AI research to transform healthcare. So this is a little fun highlight among my work when I'm working for large corporations. So technically, this is actually a work when I was at AT&T. Without any marketing, Have to Pee, as you guess, got selected by New York Times and featured as the app of the week. What it does is, not only I created a funny little graphic, the little PP dance, is actually the first consumer crowdsourcing app during the .com crash to allow AT&T to gather user feedback if that business is still in business. Do they have a restroom? We technically have a whole suite of Have to apps, but we thought, oh, no one have bathroom data. But AT&T acquired yellowpages.com, and we have a whole set of local data. And why don't we just do this kind of fun app? So we come up with this fun idea. And what it really does is not only create this convenience for people, especially living in cities, trying to find a bathroom, but really is a first crowdsourcing app, allow users to report if the business is in trouble, because during .com crash, a lot of business closed. It's difficult as a data company to understand if the business is still alive. The success of Have to Pee generated maybe like 50 publications without AT&T putting any market budgets. That actually caused a cross-sell of the entire Have to app. So like Have to Eat, Have to Drink, Have to Snack, and then also Speak for it. And what's interesting is that we end up taking the traffic we got at Have to Eat, which proven out of all the different local business categories, which is AT&T trying to find which category had the most business opportunity. It turns out people love to eat. And then we then use their Have to Eat to design a machine learning rating based on 5 different aspects of the restaurant, based on a data set that AT&T bought from City Search. at the same time, and also our data team and AT&T Interactive R&D went to clean it up. And then we designed AI algorithm to allow machine to rate a restaurant based on 5 different aspects, like atmosphere, the quality of food, the price. I forgot exactly the order 5 now. It's been a while. And what's interesting though, for me as a human-centered design expert, working side by side with the data scientist, what I helping them is creating, user behavior patterns to kind of identify, like, what are, user might likely to say and what could potentially causing data problems. So like, for example, in the case of Have to Pee, it was kind of funny, like the joke is that within a week or two, when the app launched, our data team had to put in a profanity filter because, bathroom, right? It's like an app. It's easy to make jokes, right? And then that was like a fun, interesting discovery about the data. Sorry, I'm gonna close my door. The neighbor is coming to blowing the grass. And what we discover in Have to Eat is that, so like, for example, is if a customer say, oh, today's a beautiful day. I love my girlfriend's dress. She smells so good. A lot of these sentiment will be easily picked up by the AI as like a rating of the atmosphere of the restaurant. However, when our data team started going and pull example to discover, oh, actually, no, they're not, right? So we can start design specific way to kind of pull out data and setting up rules that, so that these kind of comments won't be adding as like, a 1 point up for like the atmospheres for the restaurant. And that's just a quick example. The other app that we launched is called Speak For It. And that actually helping AT&T package the voice recognition technology, because in 2009, AT&T started panicking because they're one of the oldest lab that developed speech recognition. And that's when Google, IBM, Microsoft, they all started have speech recognition technology. AT&T, as one of the earliest pioneer, for a long period of time, they didn't know how to commercializing it. And so they end up laying off a lot of data scientists and AI, neural linguistic NLP, experts that where they are having a hard time find jobs. Usually, if you're a PhD specialized in natural language processing, if you lab in AT&T, where you're going to go? You go to other labs and start their, natural language processing, right? And so AT&T panicking in 2009 when I was working there, and they wanted to figure out how can they package their voice recognition technology and commercializing it, but they don't have enough data. So Speak For It is an app allow AT&T to, we build this mobile app, like say, imagine you're driving down the street and you wanted to find gas station. You can just talk to your phone, say gas station. And then we build in AR in the mobile app where you can pull up your phone, you can look at the gas station, you can determine which one is before you and which one's after you. So that way you can determine which one is the right one to go. We also integrate technology like multimodal, which is allow a user to actually draw a circle on the map, and then your result will be specifically limited to those circles. And what's also interesting as a human-centered design expert that working side by side with AI scientists, I also work with them to develop different scenario using my composed a sentence when they search for specific locations. So for example, somebody may say Indian restaurant, and then it turns out if they say Indian restaurant next to Empire State Building, that might actually help them find better results, right? So these are just a quick example of like how human-centered design can really make a difference in data science and in AI. So that's good with dance for healing. This is our patient Andrea dance with her buddy June. So our mission is making healthy habits, building fun and supportive. Our vision is to be a global technology leader in bridging creative arts in healthcare. But more importantly, our guiding principle is empathy, behavior design, patient advocacy. We have won over 20 awards, but most importantly, we wanted to help 100 million elders and patients. Our technology are mostly WebRTC, Node.js, React.js. We have a pattern for the AI. We currently have 2 grant pending invited by NIH in NSF. So there'll be a huge level of biosensor integration and also voice recognition to build synchronization with Alexa to build a voice interface to reduce adoption barrier for the elderly. All right, so this gives you a little example of the interface. As you can see, June is on the left, Andrea, her buddy, is on the right, and then you might not able to see right here, there's actually Easy Breezy, Mellow Bellow dance machine. Those are like 3 energy levels. On the right side, they get to choose different time frames. And it's just a quick example to show you how we cater to individuals' needs based on the energy level and the amount of time, whether they're capable or available to dance. Okay. So let me show you this video. Hopefully this works this time. It worked earlier. Uh-oh. This is what I was dealing with earlier. Oh yeah, right here. Finally.
Hi, my name is Amy Lee. I'm founder of Dance for Healing. 77% Americans suffer from physical symptoms due to stress, 73% psychological. I was one of them. In 2011, I ran a marathon. In 2012, I was fighting stage 4 cancer. It was very hard. I won the battle, discovered the healing power of music and dance, now inspired to give back to the community that supported me. When people get sick, they not only have physical fatigue, but also huge mental stress, and become a roadblock to help them heal better. Creative arts therapy improving quality of life for cancer patients by 50%, reducing pain by 59%. Dancing frequently will reduce the risk of dementia by 76%. Increase serotonin, oxytocin, and make you feel more loved and trustful. This is crucial for patients who's going through the most difficult challenge in their life. Patients are also homebound and very easy to fall into depression. We specifically designed our virtual dance platform to address this problem. Based on neuroscience, Dance for Healing uses AI, behavior design, and gamification to recommend personalized music and dance based on how you feel right now and your health condition over time. Enable them to dance with friends, family, cancer buddies, anyone, anytime, anywhere in the world.
Now open your eyes wide. Tight shape. Open wide. Tight shape.
In April 2014, we launched our first pilot. Let's see what the patient had to say within 4 weeks.
It was just a great class for me. I tell everybody that I wasn't sure about when you're on the computer. Virtual. I like that now.
I just think maybe I only can dance for minutes. Yeah. I have some muscle here. I can dance for an hour, no problem. Yeah. Really, I get my energy back.
I met an amazing group of people. We are open-minded. We want to try new things to help us. We are very brave, I think. And we dare to express ourselves, even we know that we are not the best dancers in the world. So we are so fortunate to have all the amazing teachers. You really made a difference in our life.
All right, so that give you a little bit idea. Yeah, it seems like there's slightly glitch in there in the sound. So let's go to the next one. As you probably know, many patients like me and elderly like my mom stuck at home often. lack of exercise and community support, and it's very easy to fall into depression, especially more challenging during this pandemic. And we're talking about before COVID was 75% of US population are stressed. And this number had went up to 80% during COVID. On the other side, loneliness affects 72% of Americans, 43% of seniors, and then 62% of teenagers. And sadly, from age 18 to 25 during COVID have reported 1 in 4 have attempted suicide. The effect of loneliness is more damaging than smoking 15 cigarettes a day. So we have 100 million people we like to transform their life by providing a little bit of respite, for them to enjoy creative arts during challenging times. So this is actually a 28 research paper reviewed by NIH Presidential Fellow and improve quality of life by 50%. The pain data is especially impressive. Initially it was 54 and it went up to 59 at the follow-up studies. So which means like the benefit actually sustained. And as you probably know, we are dealing with opioid crisis. So if dancing can reduce pain by 59%, why are we not doing dance, right? Exercise also proven to increase blood flow and then make tumors less aggressive. So for those who have the ability to continue doing at least minimum level of exercise during chemo and radiation, it actually allow them to increase their chemo treatment outcomes. So what's our magic source? What we really combining is my background in behavior design and also guided by IDEO and Stanford professor BJ Fox. We bring empathy to connect with users' motivation. We provide medical research data to educate them about the health benefit of creative arts. And we also personalize to their needs. As you probably know, many exercise programs, even dance programs, they're for fit people. Really, they tailor to individuals' needs. So we want to change that. Every 11 seconds in outdoor fall, every 19 minutes in outdoor die due to a fault. Dance will improve balance by 50% and prevents falling. $1 in $3 in Medicare will go to Alzheimer's by 2050. That's my mom dancing because she does not want to get dementia. So this is actually a 21-year study published in New England Journal of Medicine, and they track all kinds of activity, biking, running, golf, tennis, swimming, dancing, of course. And then they track daily activity like reading and writing, solving puzzles. And it turns out dancing is the only physical activity shows the result reducing risk of dementia. And to their surprise, the researcher went back to study the group and to see what kind of dance at that time was popular. And they found that Lindy Hop was quite popular at that time. For those who happen to know Lindy Hop, it's very much a free-form dance where, once you learn the basic steps, you just quite responsive to, you can just free to experiment and respond to the music as well as to your partners. And from a neuroscience perspective, your logical side of brain is doing mathematical calculations for the musical beats, right? Like it's 1, 2, 3, 1, 2, 3, 4. In a split a second, you have to transfer the signals to your right side of your brain, and your right side of brain have to use your body, your arms, your legs to counting the same mathematical beats, but in an artistic, beautiful, however your style, right? And that is intentional amount of decision making on the fly, both your left brain and right brain. And that's why, none of the other exercise shows a result reducing risk of dementia, and dancing actually have that power effects. And in addition to that, you guys might know this company, Lumosity, and that is like, helping people solving puzzles. So the second data is if you solve the difficult puzzle a couple times a week, you get 47%, but dancing 76%. And Lumosity, I believe they have like 15 million users. So my request for you guys is to help us share these educations, because it's so important for people to know, and so more people can adapt this powerful healing modality for yourself and your family. 1 in 3 deaths in the US are due to cardiovascular disease. This is a 20-year study in UK, 48,000 patients published by University of Sydney, indicating compared to other exercise, dance reduced 46% of cardiovascular death. So I already mentioned a little bit about our behavior design background. So this is Fox behavior model. For any behavior to happen, it requires 3 components: motivation, ability, and prompt. If any component is missing, behavior change doesn't happen. So BJ Fogg recommend that you do not try to increase somebody's motivation, because that is extremely hard. So he wants you to identify the people already motivated, increase their ability. So in our case, we identify the people who might already like dance or willing to try, or we educate them to increase their motivation, that, maybe their family find out, oh, okay, if grandpa dance a couple times a week, he might able to, reduce the risk of dementia by 76%. He might able to spend more time with his grandkids. That might be aligned with his motivation. So that's kind of how we create a motivation, by using empathy. And then most importantly, many people could have the motivation and they have the ability, and they sit there whole day and do nothing. And that is the behavior prompt comes in. And extensive research have showed that if you're in a group, you're more likely to accomplish your goal, and you even more excel when you have an accountable buddy. So that's why Dance for Healing, we not only have group classes, and then we also bring buddy, by matching them to a compatible buddy, to create a bonding experiences and to increase the engagements for the healthy habit building journey. And we are also offering pre-recorded content that is increase their ability to have 24/7 access anytime. Yeah, so this is actually one of our patients. Being an entrepreneur is hard, very hard. Unless you're really passionate, don't be an entrepreneur. And so patients comment like this is really the one that keeps me going. When I see Mary say, when I was in chemotherapy, I was a whole week just waiting for the time to go to Dance for Healing. No matter how miserable I felt or how much my joints were hurt, I knew everything would disappear while I was dancing in such a supportive environment. And Gali is actually one of our friends who wanted to try our Dance for Healing program. And she has multiple sclerosis. And before the class, she was afraid if she could even do 15 minutes. And then after class, she texted me and she said, for the first time since I was diagnosed with MS, I don't have to think before I walk to take the next step. Yeah, so inspired by these patients and also follow the medical research, we have expanded our project to not only just supporting cancer patients, but also chronic disease patients and elderly. Our NIH grant will be an intergenerational program focused on dementia patients and their care partners. And then our NSF grant is a partnership with Stanford Cardiovascular Institute that is for diabetes patients with high risk of cardiovascular health issues. So this is our initial pilot at Stanford for cancer patients. We achieved a net promoter score of 91 versus healthcare industry of 24. A majority report 4 or 3 on the scale of 0 to 4, which is 180%. In their anxiety, depression reduction, and also body energy level increased. We won about 20 awards, most recently AARP CS Annual Pitch, People's Choice Award. And most importantly, we also combining two of the best stress management tools. On the right side, if you see the graph, that is from American Psychological Association, and 47% American prefer manage stress by listening to music, 46% prefer exercise or walking. More importantly, we are following the trend of our modern society. If you looking, like consider Adam and Eve started dancing way, 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 way back. Like, I don't know how many grand parents we should say. And, and it's so deep in our roots. Like we all dance when we baby in diapers, right? Like, when you play the music, you see the baby started to bumping their head. Right? And it took centuries to invent videos, another 50 years to invent Skype. And now in 2022, especially after COVID, I declare personalized telehealth, my body platform is the future of health. On the left side, this is the economic cost impacts. As you can see, all the disease colors, we started with cancer, but we really can impact, many other chronic disease. On the right side, this is the population that impacted by different disease. And as I shared earlier, halfway through my entrepreneurial journey, I realized half my job is education. So I ended up started stage 4 Wicked Wisdom Media Network. So this is our beautiful web magazine. This is our book in cooking right now in partnership with Catherine Mayanik, who's actually the researcher behind Ray Kurzweil's book, Singularity is Near, and Peter Diamanda's book, Abundance. We have about 50 industry expert interviews that we currently, Catherine is doing data analytics for these interviews. And so it really is using my story as a launch pad to share the insight about patient and family challenges, about the power of technology, AI. We have a chapter called The Future of Medicine. And right after that, guess what? It's a chapter called Healthcare Turtle, because innovation is slow. So we wanted to share the insight, what is possible and what is also challenging. All right, so now, since I'm a futurist, I'm gonna have fun with you guys, like go one step further to talk about how do we hacking humanity with creative arts. So this might be very familiar for you guys. If you look at Hollywood, it gone through this whole transformation. One from the scary robot Terminator who come to kill all humanity versus this cute little robot Wally that is going to come and clean your garbage. Isn't that an amazing shift? And if you look at recent years in terms of a lot of robots, especially in the technology industry, is actually assisted robot, like the companionship robots, robot who, not only talk to you, understand you, or just look at you with their little eyes, yeah, so like really is this companion robot is getting really, really popular. And this one is interesting. What do you think is the hardest thing when we look at singularity in the robot? Like, can robot have emotions? I'm going to show you a clip. I hope this video works. It might take a minute to load. It was working earlier. Uh-oh.
If it doesn't work, Amy, we can put the chat link in the chat and
oh, right here, yeah. It's new click on the right. Okay, you guys are gonna have fun with this.
I think you murdered him because he was teaching you to simulate emotions and things got out of control.
I did not murder him.
But emotions don't seem like a very useful simulation for a robot.
I did not murder him.
Hell, I don't want my toaster or my vacuum cleaner appearing emotional.
I did not murder him!
Isn't that funny? Can the robot have emotion?
That one's called anger.
In the future.
Yeah, so let's go to the next one. All right. Okay, so let me go to the next one. Ah, gosh, how do I go to the next one? It seems like stuck in a little bit of cooking.
You may have to stop sharing just for a moment.
Earlier it worked. Right now it's kind of going into the nitty-gritty stuff. Oh man, sorry about that. I don't know. Yeah, PowerPoint is driving me crazy today. I'm not sure what happened here. Okay, so now I gotta go to the. Okay, let me just stop share for a minute. Let me see if I could. Sorry about that, guys. Hope you enjoy the fun so far. Okay. Okay, so hopefully this will work. Okay, all right, so let me circle back. Okay, and let's watch another clip.
Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece?
Can you?
I would laugh at Will Smith's face, but anyway, that's a legitimate question, right? Like, you know, really, the hardest part is probably, can the robot do that? But the funny thing is, look at later on in the movie, the robot draw this beautiful sketch in very detail to show the location the scientists have left him as a cue to empower Will Smith able to kind of find and solve the puzzle. All right, so I guess the interesting question is, can we use creative art to train AI to make it more human? That's an open question. Oops. Getting a little challenging with my navigation here today. Oh, there you go. And can the robot draw, paint, sing, and dance with us? Ah, check that out, right? This robot certainly makes his grandma very happy. And the funny thing is, there was a MIT story about this robot, and this is a little bit way back. The robot only have eyes and nothing else, just like the eye just sort of, you know, rotate around. And I think they did a pilot in Hong Kong. And by the end of the pilot, the participants are supposed to return the robot. But guess what? They got attached to the robot. You know, the robot only have one feature, just the eyeball, able to rotate and look at them and look at left, look at right. They got attached to the robot and they don't want to return it. Can we use creative art to educate the public? Transhumanism is really elevate the technology, elevate humanity through technology in an ethical way. So this is an example of our executive director, Natasha Vidamore, have created this sort of a Prismo post-human and allow you to see different possible technology that could enhance humanity in different ways, okay? Many of you probably hear about the book from Ray Kurzweil, The Singularity is Near, and some people might get it, other people might not. right? And Charlie Kemp, who fell in love with his book, who's a comedian and a singer, decided to create a funky video to talk about what is singularity. And this one's really interesting. Many of you know Maslow's hierarchy. So many of you probably know all the way up to here. And what's not really commonly known is Maslow actually added 3 additional needs. And you probably see here, aesthetic needs is right here. And which means that our human naturally also have this ability to appreciate arts, and music and dance have no borders, right? And then during this pandemic, you probably all heard about the Italians sing out of their window, or the neighbors start dancing on the patio, because when humanity is threatened, we really go back to our roots, and our aesthetic needs naturally come out through this desire of music, dance, and art. And then the ethics, this is the interesting part. One of my favorite TV series is Humans on Amazon, and it does a fantastic job of exploring ethics behind what if singularity does happen. And I recall that in our Humanity Plus Harvard conference, I was outside having a little debate as a human-centered design expert with Ben Gurzel, who's the co-creator of Sophia Robots with David Hansen, and also George, who both really well-known AI scientists, to debate to see if we could also train AI like we training babies with affects, since they, as soon as they're born onto this earth and started to establish these thinkings in their brain. And then the next part is Linda. And the reason I invited Linda is Linda had this amazing initiative at UC Santa Cruz. And for me, many people did not realize that how much they're influenced by media biases. And unfortunately, our modern design of AI throughout the entire social media ecosystem is designed to further and further push you into a bubble with, constantly recommending content that you might be interested. And then that, unfortunately created more divides between ethnicities, cultures, countries, like right now we have Olympic going on, and there's a lot of debate on that as well, right? So I love for Linda to share a few minutes about what she's doing. Linda, go ahead.
Oh, thank you. Thank you, Amy. It's a pleasure to be here. In terms of a brief background, Amy and I have been friends for a long time. She is very inspiring. She helped me through my own bout with cancer last year. And so she and I have had so many fascinating discussions about the ethics of emerging technologies. My background is, I refer to myself as a recovering attorney, but I also have a background in philosophy, ethics, and have my degree in biomedical ethics, clinical ethicist. So at UC Santa Cruz, we've started the Center for Values and Ethics and Applied Values. Sorry, there's one word missing there. It should be the Center for Applied Values and Ethics and Advanced Technologies. Is caveat for short. If you can go on to the next slide.
Okay.
As Amy pointed out, like so many other technologies, AI can be used for tremendous good, and a lot of films and media portrays, well, that AI will take down humanity, or in Ex Machina, for example, well, it seems the message there is if you're a psychopath and you create something in your own image, it's going to be psychopathic. To a recent movie in 2021 called I'm Your Man, which is sort of a lighthearted, but yet very thoughtful and provocative look at how AI can make us better humans. So there's so many issues, and I don't want to take up a lot of time, but we have a special project at the center. If you can go to the next slide. In data science, and I'm sure among everyone here, there's the discussions of data equity, how do we make sure that there aren't inherent biases in algorithms and how the data is collected. But one of the things we're looking at UC Santa Cruz is how the data is used once it is collected, this concept of data dignity. We're working with Consoli.net and forming the Data Dignity Alliance, which is basically, the fact right now is that data is often collected for commercial value, not necessarily to address broader societal issues, environmental issues. So how do we take how data is being used and make it into part of a regenerative economy where everyone benefits, not just a few? So it's, for example, data brokers. I don't know how many of you are aware of the policy surrounding data brokers, but data brokers, there's only about 6 or 7 of them in the United States. They gather your data, and at the same time, they also sell, while they're selling your data, they will also try to sell you software that will protect your data. Now, I grew up on the East Coast in New Jersey. To me, that's called a racket. Hey, that's some nice data you got. It'd be a shame if something would have happened to it. So I think this is a really important issue. Amy is the one who introduced me to this group. I'm looking forward to joining it and to further discussions. If anybody wants to contact me, I forgot to put my email in there. It's I'm going to type it into the chat.
Yeah, you can put it in the chat.
It's, yeah.
Okay. All right. Wonderful. Thank you so much, Linda.
Thank you. And I'll be happy to answer any questions if there are anything.
All right. So the next thing, what I want to bring to this conversation is that in all dimensions of hacking humanity, most important thing is actually communication. Communication and leadership. And I'm speaking from my 5 years of experience, working through my personal breakthroughs in team management and leadership program. And this is my favorite quote. A leader is best when people barely know he exists. When his work is done, his aim fulfilled, they will all say, we did it ourselves. And this is from Lao Tzu. And what I really wanted to, encourage you guys is to really look within yourself, that little powerful leader that you have since you were a child, and allow your leadership to shine and allow you to identify the leadership in other people and empower their leadership to shine. So together, we can, continue to work, AI technology, bring ethics into these technology development, and really co-creating and transform our society, especially after COVID. The impact of COVID is going to be long lasting, right? And so by bringing these kind of awareness of social responsibility and empower our leadership to shine, and help us share some of these education today, we can really transform the world together. And lastly, we want to invite you to join our movement. We're certainly looking for partners to set up pay pilots, healthcare guru to help us figure out, how do we maximize the opportunity for the beneficiaries. And then technologists who wanted to contribute to our voice UI development or the AI development, and also ambassadors who can help us educate the public, and then social impact investors. And I wanted to invite you to watch this little video and see the kind of impact that we could co-create together.
La la into the exercise room.
That was awesome. Yay. Yeah, so as part of the Stanford Staff Garage, we had to conduct country interviews, and we met her, and she has dementia, so she's not really able to communicate much. So she started to dance for us. And I just wanted to share this to empower you to be able to see the joy, how simple music, dance, and art can bring so much joy to the elderly. All right, so join us, dance with us like no one is watching. And we open for questions. Stop share. All right.
Thank you. Thank you for the wonderful presentation and so inspiring. Yeah, she's open up for questions. So if anybody has any questions regarding, so what is your next step? I mean, there's so much you can do in this space. So where is your next step gonna be? How do we make it available to?
We currently waiting to hear back from NIH and NSF for our SBIR grant, and both of grants focus on the technology development like voice recognition AI synchronized with Alexa, and also bio-tracking to able to scientifically prove and do data that the impact of creative arts. I actually just have a conversation with the head of art and health at WHO on Friday, and that was very inspiring to know WHO also have an interest to not only educate the public about the health benefit of creative arts, they also willing to partner or collaborate with industry and academics to conduct the research behind art in health, and then showcase this research. I think the silver linings pandemic definitely bringing a lot of awareness, like how much humanity needs the art. And then, and in our, when I was talking to Christopher from WHO, he really appreciated my vision that Dance for Healing to be a global cultural hub, and experienced leader in bridge art and health. And so we imagine, we're going to bring arts and culture from countries that are already rich. And this is actually very aligned with UN's sustainability goal as a preserve world's heritage. And also leveling the field for economy, when you're able to empower artists from countries like, South America, India, Africa to teach art, music, and dance through our platform or share the video through our platform, that also increase their ability to generate income. Yeah, so that's our next step. And we're looking for pay pilots if anybody have connections to insurance payers or like health center that more open-minded about innovation.
Absolutely. Thank you. We will spread the word to our network. Amazing, very noble, amazing cause. So great to have you here, both you and Linda. We really appreciate your presentation.
Thank you. Pleasure to be here.
Yeah, please feel free to follow up with them. They have provided their contact information. There's so much we can do as individuals to help spread this message, right? Art's a part and parcel of every culture, right? Every part of the world, every culture has some form. Why not use it to our advantage, right? To help our elderly and help our sick people who are sick.
Yeah, I just put my LinkedIn in the chat. So anybody want to connect with me on LinkedIn? One of the things we also see, especially during this pandemic, with other, Asian hates and Black Lives Matters, we also see art is a bonding agent, and we create that humanity or understanding. And also, because our music dance had no borders, right? And if we could start to having more appreciation of different regions of long history of arts and culture and heritage, we're gonna start to seeing that humanity regardless of age and gender and race, and started to reduce these kind of like conflicts around the world. Yeah,
absolutely. Yeah, it's a medium for bringing people together. Yeah, absolutely.
Yeah, exactly. Yeah. Do you guys have any questions about ethics for Linda?
So you talked, Linda, I don't know if you got, there was a question about, the brokers, right? They sell they collect all the data because they can, and then they sell it for profit. So what the regulations we have currently in our country and other parts of the world, so like the GDPR and all, why isn't that putting a brake on these people? What's missing, or is there a gap?
So good question. What happened was you mentioned the CC. I'm sorry, what was it?
That's a California personal data protection. Yeah,
that helps, but the FCC also had and Consumer Protection Agency had rules in place for a long time. Let's see now. Oh, okay, yeah, for a long time, and they were repealed. Let's see now. They were repealed a long time ago, sadly. And I think it might have been under the Obama administration. They have not yet been reinstated. And there's these inherent conflicts of interest where what happens is that the data brokers, yeah, they collect the data, they sell it to others, and then they will say to you, oh, let us sell you a product to protect your data. And like I said, that sounds like a racket to me. I'll be actually publishing an article shortly about that. And we need to bolster. I mean, Elizabeth Warren, and I'm sorry, I forget who the other senator is fighting to reinstate those protections so that if there is a conflict of interest such as that, they need to declare it, or something needs to be done about it. So, but I look forward to our future discussions, and I invite you all to connect. Oh, my earphones are dying. I'm sorry.
Yeah, I think you're right. We have to put pressure on our policymakers to get there. But first and foremost, we need to make people aware that this is happening, right? Very few people actually know that this is going on. That's right. So good you brought this up and made us aware, and hopefully we'll make more people aware that this is going on, and this is the way we can pressure our policymakers to put things in place so that this doesn't happen.
Thank you. Yeah.
One other comment I wanted to add, like just by looking at the chat, there's quite a bit of comments about emotion. So one of the things that we at Dance for Healing, that is also one area we're looking into. So our initial pattern name was going to be mood-based intervention. But we end up including, so many different dimensions of recommendation. The eventual name is method and system for personalized recommendation of music and dance. However, emotion is always an important part of our work, because the power of creative arts is not only mental and physical and also emotional, right? So there are ways we're looking into. At the phase 1 Guan, it might be kind of hard to dive deep into the emotion side of it. But for phase 2 of SBIR Guan, we are looking into emotion research by computer visions, a combination of sentiment analysis of voice. And then it turns out there's even potential to use voice to detect somebody's early onset of dementia. And voice has been used in like calling centers, especially in Europe, to detect somebody's stress level So it has already had a long history of like, associated with emotions. Yeah, so it could be really interesting. We did build our early version of prototype at TechCrunch using computer vision, using a MIT API for facial recognition. It was quite fun. The only challenges with computer vision is the data processing is very expensive. So hopefully over the years, it might go, lower cost, and then that facial recognition, might be possible, in terms of detect somebody's emotion levels. My experience at AT&T allowed me to having a broader level of able to looking in data, like a multi way to combining data and double checking the data. Like say right now for the NIH and NSF grant, like our AI is going to combining our platform data, the biosensor data, the voice data, and then also self-report data. And that in itself is already an interesting way to research how do you combining data. Yeah.
There are challenges in kind of bringing together and integrating and then making sense out of that data, right? Coming from so many great sources.
Yeah, it could be complicated. And then if we develop the right protocol of the bio data collection and integration of this different set of data, it could be a huge contribution to other organizations and companies as well.
And then, making sure that, things are moving to the edge now, right? Everything is trying to go to the edge devices and so on. So that's another consideration for the future.
Yeah.
How do you kind of manage everything on the edge to keep the data privacy right over there?
Yeah, and that's another area Linda could probably talk about is like the emotions, even with computer vision, facial recognition. I don't know if you guys hear, just a couple of days ago, IRS decided to stop this contract because it was using, it was using, I think it was facial recognition to confirm somebody's identity. And there was a lot of backfire about the privacy issues, and they end up announced they stopped the contract. Yeah. So it's going to be complicated. And so, as a community, how do we bring these ethical practice in different dimensions? And then, how do we create sort of this nice balance of like, we could use technology to enhance, human capacity to bring more health and wellness to humanity. At the same time, also have, enough integrity and awareness to protect privacy and security. Yeah, it's a delicate dance.
Delicate balance, yes, for sure.
Yeah.
I'll have to dance around that.
Yeah, and to improve, to make a more fair, just, and equitable future for everyone.
Absolutely.
Yeah. Oh, and that's another one that when you're asking what's the next step for us, is really our research through like writing the NIH in a subgrant totally open up awareness of health disparity in the US and likely probably around the world. So that's also an area we want to look into. Like a quick example would be African American actually have the highest rate of high blood pressure in the world. And then that lead to overweight, diabetes, cardiovascular health issues. And then in the longer term, it also lead to Alzheimer's, which is totally, to my surprise, I didn't even know that has that long-term impact. And so according to the data that we gather, about twice as more for African American and 1.5 times more for Hispanic to have higher risk than the whites to have Alzheimer's. And unfortunately, majority of them don't get diagnosed until later stage. And that will cause the medical costs to treat these specific population in about 1/3 more cost for them at a later stage of diagnosis. Yeah, so that's an area that we definitely want to look into. And from a data perspective, as you probably know, a lot of clinical trials, majority of the data, unfortunately, coming from Caucasians, right? And minority representation has been long lacking in clinical trials, probably due recruitment challenges. At the same time, also there may be some mindset challenges as well. And so that unfortunately creates a lot of skewer about, even in COVID, like, there was multiple cases of minority, they were positive, but their test result was showing negative. And then they end up, really damage their body until they finally, the doctor say this patient have all the symptoms, they do have COVID, despite the fact the test result is negative, and that just shows you that skewer of the risk of having the clinical trial being so that this unbalanced population of ethnicities and different sort of backgrounds, and genders that could really create these biases. Yeah.
Absolutely. All right. Well, thank you so much. It was such a fascinating talk and discussion, and we're so happy to kind of wrap up this day with that. So thank you again, Amy and Linda, for this wonderful conversation, and thank you for all the participants and hanging in there. It was a long 4 hours, but you stood there. So I hope you got something out of it. And please feel free to connect with and network with and help out each other. This is the community, so in any way you can make a difference, please connect with each other and help out. Yeah, and we'll see you again next Saturday. We have some more talks, so we'll see you there then. Thank you, and have a great rest of your weekend.
Thank you. Okay,
Thank
bye.
you. Bye.